Now, we will discuss one of the main components of the Ethereum blockchain, which is the Ethereum Virtual Machine, or EVM. The Ethereum Virtual Machine allows users to create decentralized applications on the Ethereum platform. An example of a decentralized application is a smart contract. You can connect to the main Ethereum network via the EVM, or you can simply build a blockchain and use it for testing purposes. Since the Ethereum Virtual Machine is completely isolated from the rest of the main network, it is the perfect testing environment. Any instructions you give the EVM will be executed on every node that is present on that network. Ethereum is a programmable blockchain. It gives users a set of predefined operations and allows users to create their own operations at any level of complexity they wish. In this way, it serves as a platform for many different types of decentralized blockchain applications, including but not limited to cryptocurrencies. Ethereum, in a narrow sense, refers to a suite of protocols that define a platform for decentralized applications. At the heart of these is the Ethereum Virtual Machine, which can execute code of arbitrary algorithmic complexity. In computer science terms, Ethereum is Turing complete. Developers can create applications that run on the EVM, using friendly programming languages modeled on existing languages such as JavaScript and Python. Like any blockchain, Ethereum also includes a peer-to-peer network protocol. The Ethereum blockchain database is maintained and updated by many nodes connected to the network. Each and every node of the network runs the EVM and executes the same instructions. For this reason, Ethereum is sometimes described evocatively as a world computer. This massive parallelization of computing across the entire Ethereum network is not done to make computation more efficient. In fact, this process makes computation on Ethereum slower and more expensive than on a traditional computer. Rather, every Ethereum node runs the EVM in order to maintain consensus across the blockchain. Decentralized consensus gives Ethereum extreme levels of fault tolerance, ensures zero downtime, and makes data stored on the blockchain forever unchangeable and censorship-resistant. Similar to programming languages, it is up to entrepreneurs and developers to decide what Ethereum should be used for. However, it is clear that certain application types benefit more than others from Ethereum's capabilities. Specifically, Ethereum is suited for applications that automate direct interaction between peers or facilitate coordinated group action across a network. For example, there are applications for coordinating peer-to-peer marketplaces or the automation of complex financial contracts. Bitcoin allows for individuals to exchange cash without involving any middlemen, such as financial institutions, banks, or governments. Ethereum's impact may be more far-reaching. In theory, financial interactions or exchanges of any complexity could be carried out automatically and totally reliably using code running on Ethereum. Beyond financial applications, any environment where trust, security, and permanence are important, for instance, asset registries, voting, governance, and the Internet of Things, could be massively impacted by the Ethereum platform. So, this is the relevant information about the Ethereum Virtual Machine. In the upcoming section, we will discuss the programming language, Solidity, used for developing Ethereum dApps.